A square matrix is symmetric if it's equal to its transpose. So in other words, the entries in row I, column J, are equal to the entries in row J, column I. So examples can be seen over here, where if you transpose this matrix, you get the same matrix. So row 2, column 3 is equal to row 3, column 2, and so on. So we can see that all diagonal matrices are symmetric due to having all zeros off the diagonal. So you can imagine that if you add two symmetric matrices or subtract them, then the result will be a symmetric matrix. And if you multiply a symmetric matrix by a scalar, the resulting matrix will also be symmetric. And in general, the products of symmetric matrices are not symmetric, but only in a special case where S1 and S2 commute. And if a symmetric matrix S is invertible, then the inverse of this matrix is also symmetric.